All right, let's keep working through these. Here on 31, they want us to expand the logarithm, and we have log base b of y times z to the sixth. So that's going to leave us with, when we multiply our argument, it's going to be log base b. That turns into an addition. So log base b of y plus log base b of z to the sixth, and then that 6 can actually move out front. So we're going to have log base b of y plus 6 log base b of z. I'm looking through my answers, and I see that the best option here will be option C. 32, same type of problem. It's going to be log base 2 of 4 minus log base 2 of x. Well, I know log base 2 of 4. I know that that's just going to be 2 minus log base 2 of x, and that's going to be option D. Here we're going to move into some trig. They want us to find the exact value of the cotangent of 3 pi over 4. So that's in our second quadrant. So this is going to be negative. So that right off the bat, I can eliminate option C and option A. 3 pi over 4, that is a reference angle of 45 degrees. The x value and y value will have the same absolute value, but opposite signs. The cotangent of 3 pi over 4 is -1, making option D the best option. On number 34, we are modeling the behavior of a spring pulled below equilibrium and modeling the situation. So we are going to pull the spring below equilibrium, which means that we are starting at a low point. So I want my A value, the multiplier out front, to be -5. So right then I can eliminate options A and C. So you can see what's different between these two options is that B value, the argument. So we have to use what they tell us about the, in this case, the frequency. So the frequency is the same as 1 over the period. In other words, it is the reciprocal of the period. So our period here is pi over 6. So in order to find our B value, I take 2 pi and divide it by the period. In this case, I will have 12 pi over pi, or 12. That B value is what's going in right here. I can see that that 12 matches what I found for my B value, making D the best option. On to 35 here. We have two trig graphs, 2 times the cosine of x and the cosine of 4x. So this is vertically stretched. This is horizontally compressed. So why am I mentioning that? Well, there's a couple things I want to, this can be a confusing problem is kind of where I'm starting here. You can see some of the graphs are a little bit strange looking. So I'm thinking about a few different things as I approach this. I know that cosine, both of these functions have been not been shifted right or left. So this function and this function both have a maximum at 0. So a maximum on this first function would be at y equals 2, and then here at y equals 1. So I need to have a y value of 3 at when x equals 0. That does work here. It doesn't for B, it doesn't for D, and it doesn't for C. So even though this graph is complicated and may be something that you haven't seen before, if I know just a little bit about the starting point of cosine, I can really zero in on a single point that when I add together 2 plus 1, I reach 3. It's the only graph that has that quality. Let's pick the right answer and move on. So here on 36, they are asking us for a coterminal angle that is less than 360 degrees. coterminal with 668? Well, right off the bat, I can eliminate option C. Sorry about that. Because that is not less than 360. Make sure we're just paying attention to details. I'm going to take 668 minus 360 and see what I get. Well, I'm going to get 308 degrees. That's less than 360. Therefore, option D is the best one. Here on 37, they are asking us to find, they're asking us to solve the triangle. They want us to find all the side lengths and all the angles. Well, it's not as complicated as it seems. Let's focus on the angles first. I know that all three angles should add up to 180, meaning this angle here must be 45 degrees. Well, if I look at B and D, they have the angle wrong. So I can eliminate those answers right now. And then I can kind of zero in on what's different between option A and option C. Well, in option A, side length A is 8.11, and in option C, that's side length C. We can see that the other side length is also flipped. So really, this is asking us, do we know which side should be longer, A or C? Well, the angle across from an 80 degree, the side across from an 80 degree angle would be bigger than the side across from a 55 degree angle. So the option where C is larger, option A, is the best one. Moving on to number 38, we are going to try to find the area of a triangle. You can see I looked ahead here and drew a picture. They tell us that we have an angle of 27 degrees, and I labeled my sides. They're somewhat arbitrary, but what I'm going to do here is I'm going to try to find the height of this triangle using some right triangle trig, and then multiply that times half of 5 for my area formula. So I can see I would set this up as a sine function. The sine of 27 is going to equal h over 14. So h will equal 14, times the sine of 27. We are going to multiply that height times half of 5. And once we plug that into our calculator, we get 15.89. We can round that up to 16 square inches. Number 39 here, we have another right triangle trig problem. I'm going to draw a picture here in just a second, but we have a surveyor standing 52 meters from the base of a building, measures the angle to the top of the building, 36 degrees. So up like this, the angle here is 36. Then the surveyor then measures the angle to the top of the radio tower and found that that angle is 48. I'm going to use a different color here just to tell the difference. We're going up to a higher point, and this angle is 48 degrees. So that is the top of our building, and we can see what we're really looking for is this height here. So we're going to find the height of the tower and subtract from it the height of the building. In both cases here, I would be using the tangent function. I would evaluate 52 times the tangent of 48 degrees, and then subtract from that 52 times the tangent of 36. When it's all said and done, we end up just shy of 20 meters, which means that option C is our best bet. Last one here, we want to try to find the angle of a triangle with given measurements. They tell us that, again, I'm going to draw a picture here. Angle B is 10 degrees, relatively low. A, so let's make sure we label here. This is going to be A and C. A is 2 and C is 10. I can see that my diagram's a little out of whack here, but what I'm going to do is I'm going to try to find the height of this triangle. Let me just redraw this a little bit. I'm going to try to find the height of this triangle. It's going to be a sine of 10 will equal this height divided by 10. So 10 sine of 10 will equal our height. I'm going to use my calculator to find that. And I find that the height of this triangle is 1.736. I'm going to multiply that times 1, which is 1/2 the base. So that ends up being my area. So that's for number 40. We're going to square that up to 2 square feet, and we're done for this section.